In today's discussion, we are going to discuss Cartesian plane approach of defining the six trigonometric functions. So we have Cartesian plane approach. The first approach that we had in defining the six trigonometric functions, right triangle approach. But again, that is limited only to trigonometric functions of positive acute angle. If you want trigonometric functions of any angle, so we have to make use of this second approach, which is called Cartesian plane approach. But of course, before we can do this, let us have some definitions of terms and principles. Starting with angles as to direction of rotations. So we say that angles can be classified in different ways. One way of classifying angles as to amount of rotation. And then also we have as to relationships. So another way of classifying angles as to what? As to direction of rotations. Okay, so we have kinds of angles. As to direction of rotation. When say rotation, direction, so we mean either counterclockwise or clockwise. Number one, we have positive angle. What do we mean by a positive angle? So when you say positive angle, this is an angle formed by rotating the initial side in counterclockwise direction. In counterclockwise direction. Okay? So for instance, if I have this angle, let's say this is my initial side. So I'm going to rotate it in counterclockwise direction. So getting, for instance, this as terminal side. Okay? So to denote counterclockwise direction, the arrow goes this way. So let's say this is theta. So we say that theta is a positive angle. So that is theta is greater than 0 degree if it is in radian measure, and or theta is greater than 0 if it is in theta is greater than 0 degree if it is in degree measure, and greater than 0 if in radian measure. No? Number 2, we have negative angle. So how do we define a negative angle? So when we say negative angle, it is an angle formed by rotating the initial side in what direction this time? In clockwise direction. Clockwise direction. Clockwise direction means same direction with the movement of the hands of a clock. No? Let us consider this angle. Let's say I have this angle, my initial side, and then let's say this is my terminal side. So to denote that this is initial, the tail of the arrow should be pointing here. And then the arrowhead pointing to this ray below. So this, if this is beta, so we say that beta is what? A negative angle. Okay? Now, this negative, positive refer only to directions, no, of rotation. But if you talk of size, for instance, if I have negative 90 degrees and then the other one is, let's say, 40 degrees, when it comes to size, still the negative 90 has a larger size, no? The negative there indicates only that the direction of what? Of the angle, no? How it is rotated from the initial going to terminal. Negative, it is in clockwise direction. Positive, counterclockwise. So that is what it means, no? We're going to use these concepts in defining what we call standard angle in standard position. So we have what we call angle in standard position. When do we say that an angle is in a standard position? Now, to define an angle in standard position, we're going to make use of a Cartesian plane. An angle is said to be in a standard position relative or with respect to. Relative to the Cartesian plane if the following two conditions hold. Number one, the vertex of the angle is located at the origin. And the second condition, that needs to be satisfied. Its initial side is located on the positive x-axis. Again, its initial side is located on the positive x-axis. Okay, so these are the two conditions that need to be satisfied in order for the angle to be in what? In standard position. Is that clear, guys? Do you have any question? Angle in standard position. In standard position. Okay, so let's illustrate that. So let's say I have this Cartesian plane. Then let me draw an angle. So let's say this is the angle that I'm going to draw. So for this to be an angle in standard position, so let's check the vertex. Is it at the origin? Yes. The arrow should be from the positive x-axis, meaning from the initial side. This will serve as the initial side. And the arrowhead will be pointing to this. So we say that if this is theta, theta is an angle in standard position. Okay, guys? Did you understand, guys? Guys?
Yes po.
Okay. So let's have one more. So let's say I have this Cartesian plane. And if this is the angle that I have, let's say this is the terminal side and this is the initial side. So again, to denote that this is an initial side and terminal, you have to draw an arrow. So let's say this is my arrow going to this terminal side. Let's call this gamma. So gamma is said to be an angle in standard position. Standard position. Okay, now why is it in standard position, guys? Where is the location of the vertex? At the origin. How will I know that this is the initial side? Because of the arrow, no? The arrow tail, the tail of the arrow is pointing here and the arrowhead is pointing to this. Therefore, this serves as the terminal and the one that is lying on the positive x-axis is the initial. Let's say if I drew it this way, so the arrow going here, it's no longer in standard position because this will serve this time as the initial and it is not falling on the positive x-axis. And lambda here, I mean gamma here is negative angle, while theta is positive. What about this one, guys? Y, and then let's say I have here X. So this is my angle. Let's call it alpha. Is alpha positive or negative angle, guys? Who's the president? The president has to call a name in case I ask question. What is
Yes.
alpha?
Positive, sir.
Negative or positive?
Positive, sir.
So it is.
Positive.
How will you know that it's positive? There's no arrow. I'll put arrow.
Negative, sir.
It's now negative. So alpha is negative. Is it in standard position?
No, sir.
So alpha is an angle not in standard position. What is violated, guys? What is violated here?
The
Huh?
initial side po is not in the x-axis.
The initial side is actually in the second quadrant, no? Not lying on the positive x-axis. So there is one violation. What about if I have this angle? I'm sorry. So if I rotate it this way, is it positive or negative? Let's say this is phi. What can you say about phi? Positive or negative?
Positive, sir.
Positive.
Yeah.
Why is it positive?
Going counterclockwise.
Counterclockwise direction, no? Drawn in counterclockwise direction. Is it in standard position or not?
Standard.
No, sir.
Not, no? Why is it not in standard position?
The vertex isn't in the origin.
It's not at the origin, no? Standard, not in standard position. Now, the reason why we have to define angle in standard position again, so that when you're asked to draw an angle, all of us will have the same sketch, okay? Uniform sketch. So from now on, when I say draw the angle, even I don't mention it positive, I mean in standard position, you have to consider that when you're asked to draw in the Cartesian plane, you have to consider that an angle in standard position, okay? Now, another that you can associate with an angle in standard position is what we call coterminal angles. By the way, so let's say I ask you to draw the angle. Let's say draw example. Draw the given angle. Draw the given angle. Given angle. So even I don't mention in standard position, from now on, I mean it in standard position. Huh? Let's say I forget to put, unless otherwise stated. No. So draw the given angle in standard position. By the way, what are the two common ways of measuring an angle in terms of units? What are the units that we can use? The commonly used one. degree measure and radian measure, no? Okay. So number one, let's say I ask you to draw negative 225 degrees. So negative 225 degrees is a negative angle. So what is the direction, guys? What's the direction when I draw
Clockwise.
clockwise, no? So we have 225 negative. Okay, so I think my Cartesian is not convenient for the angle that I'm going to draw. So let's move a little the x-axis. In what quadrant will the terminal side fall? What do you think? In what quadrant will it fall, guys? Huh? So 225, this is negative
Quadrant
180.
2, sir.
So this is negative 180, no? Or 180 in terms of amount. And this is clockwise because I want it negative. 180 plus what? Plus 45, no? Since it is counter, I mean, it is clockwise, so it's negative. So it is in between this negative x-axis and positive y-axis. No? So here. So that is the approximate sketch. Okay? So I'm going to rotate this way. So that is negative 225 degrees. So meaning this angle between the negative x-axis and the terminal side is 45 degrees. No? What about number 2? 5 times pi over 2. So that is automatic, or that means in radian measure. No? So how much is that? How large is that angle, guys? Huh? How large is that angle? Where's my calculator? Guys, I'm not talking to, I'm talking to, I think, the sleeping people. Guys, how much? Don't chat, huh? Because I don't see the chat box.
810.
Okay? What? How much is that in terms of degrees?
810.
Huh?
810 po.
I can't hear.
Oh,
Iho, could you please check your mic, the one who is speaking?
450 po.
450 degrees, no? So how many complete rotations?
1, sir.
One complete, yeah.
One complete rotation plus 90 degrees, right now?
Yes, sir.
Yes, sir.
So we have, the line is not getting straight. So this is X, this is Y. So let's have, so 90, I think it will fall here, no? Is that right? Will fall here?
Yes po.
Yes, sir.
And the initial side is here. So to mean it 450 degrees, So we are going to rotate one complete rotation plus 90. So that's the 450 degrees, or that is 5 pi over 2. Yan. Okay now, guys?
Yes, sir.
Yes
So let's
po.
now have another important term associated in dealing with an angle in standard position. We have what we call coterminal angles. Coterminal angles. What do you mean by coterminal angles?
Sir, these are angles that end on the
So these are angles.
choppy, sir,
Sir,
choppy.
sir, these are angles in standard position that have a common terminal side.
Oh, yes, very good. In standard position,
Yes, sir.
Sir, choppy.
whose terminal sides coincide. Okay? So having a common terminal side coincide. Terminal sides coincide. Meaning having a common terminal side. So one example, we have 90 degrees. No? 90 degrees is an example of and what? And
450.
450 degrees. Okay. So if I'm going to draw them, so their terminal sides will coincide. So yx, so we have 90 degrees. So falling here, no? And this is the initial. So I'm going to draw first one arrow, 90. That is 90 degrees. Let's have another arrow. This time 450. One, then this. So 90 and 450 respective. Okay? Or terminal angles. What about if I have this angle? This angle, for instance. And what about, oh, so here, this is X, Y, and then I have to, let's consider blue. Let's say I have this angle. Terminal side, initial. So let's say I have this as my alpha and another one. This angle, let's say, sorry, this one. What about that? Let's call that beta. So are beta and alpha coterminal, guys?
Yes, sir.
So we say that alpha and beta are coterminal angles. Coterminal angles. What is the formula to get a coterminal to a given angle?
Angle plus 360 degrees x.
So, formula, no? Formula to get the coterminal. So let's say we have theta. So, is there any angle in standard position? And let's say beta is the coterminal. So how to solve for beta? Beta is equal to theta plus what? 360 degrees times what? Times n. Or if it is in terms of radian measure, theta plus what? Plus 2 pi n, no? Where
Yes,
here,
sir.
Yes, sir.
where theta, any angle in standard position, while beta, coterminal of angle of, or can be 2, coterminal angle or with coterminal angle of theta. And what about n? What can we say about n? It is equal to plus or minus 1, plus or minus 2, and so on. Okay? Now, some books include 0, no? But if it is 0, it is just the same with theta, the beta. So if you want your coterminal different from theta, so you have either plus or minus 1, plus or minus 2, plus or minus 3 for n. So let us have an example. We have determine the first two angles, determine the first two coterminal negative and positive, negative and positive. So how many all in all? Guys, determine the first two coterminal angles closest to let's say 75 degrees, 20 minutes. So we let theta to be what? How many all in all, guys?
4 po ba?
4, no? So the first two positive, let's start with the positive. So for the positive, for beta greater than 0, you want it to be greater than 0 degree if you want it in terms of degrees. So we have beta 1 to mean it the first positive, that is theta 75 degrees, 20 minutes, plus how many 360 degrees? 1, no? So you just compute. Then give me the answer later. beta sub 2, 75 degrees, 20 minutes, plus 360 degrees times 2, or that is 720 degrees, no? So 360, or what's the answer? Plus 360 degrees, 75 degrees, 20 minutes. Guys, for negative angle, b sub negative 1. Hi guys, what is the first angle? Ayaw sumagot. Miss President. Well, who are you going to call?
For 35 degrees, 20 minutes.
400,
35.
35,
Mm.
35 degrees.
20 minutes.
Is that correct? Hmm?
Yeah.
Yes, sir, it's correct.
What about the second one?
795 degrees, 20 minutes.
795 degrees, 20 minutes. You just check answer. What about for the first negative that is closest? No? -75 degrees plus 360 times -1 for the first one. Then the second one times -2 to the 360. What's the answer? Huh?
Negative 284 degrees.
Negative 284 degrees,
40 minutes.
40 minutes. No? Then the other one, guys, negative 644. Is that correct? Degrees, 40 minutes. Is that right? Guys?
Yes, sir.
Okay. So that's it. Okay. So another important term associated with this is what we call quadrantal angles. Quadrantal angles. What do we mean by...
Sir, yung sa beta negative 1, 284 lang po.
284? Sorry. I have an excess of 0 because I'm thinking of 40. My hand was fast writing the 40 because that was for 40 minutes. Thank you. I think I ran out of chalk. Correct now? Okay now, guys? So again, another important term that you need to know, we have what we call quadrantal angles. What is a quadrantal angle, guys?
Sir, is it yung mga 90 degrees, 180 degrees, 270, mga ganun po?
How are you going to describe those?
Yung like angles per quadrant, ganun po.
So this is an angle in standard position whose terminal side terminates where? Terminal
X and Y
side
axis.
coincides with what? With
X or Y axis.
coordinate axis na, with the coordinate axis. So that is either x-axis or y-axis, no? Is that right, guys?
Yes, sir.
I think I am noticing that there are very few answering. What about others? Others, I think they are already taking their lunch, no?
Still here, sir.
Where?
Andito pa po, sir.
Boy.
Mamaya na mag-lunch. Kaya pa naman.
Okay. So again, quadrantal angle is any angle in standard position whose terminal side terminates with the coordinate axis, no? Either x-axis or y-axis. So for instance, like what one of you told, so 90 degrees is an example of a quadrantal angle. 90 degrees. Yan. Okay. 90. What about 270 degrees? Negative. No? Yan. It's coterminal, negative 270 degrees. That's also what? A quadrantal angle. Aside from such, we have what? Pi. Is pi a quadrantal angle, guys?
Yes.
What about negative 3 pi over 2? 720 degrees. 540 degrees.
Yeah. Quadrantal angle sila.
Are they all quadrantal?
Yes.
Okay. So what about 0 degree or 0 region?
I think it is kasi it still
Yes,
coincides
it is
with
also
x-axis.
a quadrantal angle. Okay. One more. So we have another term, angle in a quadrant. If we have quadrantal angles, we also have angles in a quadrant. So we call it angles in a quadrant. In a quadrant. What do we mean by this angle in a quadrant, guys? What do you mean by angle in a quadrant?
Is it the angles that do not coincide with the coordinate axis?
Yes, no? So it means where is the terminal side?
Ano oras ka balik? Umupo sila. Ha? Mamayang pagbalik mo. Pagbalik ko, Manong.
Okay, so we have, so there are 4 under here. We have what we call first quadrant angle. First quadrant angle. So what is a first quadrant angle, guys? So we have first quadrant angle. First quadrant angle. What is a first quadrant angle?
Angle between 0 to 90.
No, not just 0 to 90. Those are just some of them. So in general,
Angle where both
so
x and y is positive.
an angle in standard position with what? With terminal side falling where?
The first quadrant.
With terminal side falling in the, or in the, no? Falling in quadrant 1. So what are the examples of this? What angle? 30 degrees?
45.
Pi over 4, yes. No? So, like this angle. Yan. So that is an example of a first quadrant angle. Of course, the arrow should be like this. That is theta. Is it possible also to be this one? Is that a first quadrant angle also?
Yes.
No? So theta and beta are first quadrant angles. No? First quadrant. Aside from being first quadrant, they are coterminal also. First quadrant angles. Actually, I do not want the term for quadrantal angles, because if you are going to look at quadrantal angle, it sounds like it is the angle in a quadrant, not quadrantal angle, but it's not. So what they have, so quadrantal angle, an angle whose terminal side falling on the coordinate axis. Okay. So I think better to have what word you can come up to so that it is something related to axis. So axial angle. No? I think better to introduce a new term for this. Axial angle, and the one that is quadrantal is really the first quadrant angle, for instance, second quadrant angle. So we have number 2. What's number 2? Second quadrant. So you know already second quadrant, no? So it's still the same, of course. We just copy this. So let's copy. Copy this, copy. Lasso. Copy all these things, and then copy, and then we have in the second quadrant, I mean next slide, copy paste. Yan. And then, there is, wait a minute, because of this, let me erase this one. See? Do you know what I am doing? Do you know this in PowerPoint? Huh? By the way, do you know that you have a free Microsoft 365 from the LSU? Do you know that? You can install that. Guys, do you know?
Yes, sir.
So you can install that in your computer. So this is second. What else to be changed? So this is, and this one. So we revise this as second quadrant. This is second quadrant angle. But of course the figure, I have to also revise the figure. Let's erase everything. So I want it to be where? Here, in the second quadrant. Can you now manage to define the third and the fourth? I'm going to leave that to you, no? So that we can save time. So you know things that you have to change. So these are are a sample representation. So this angle, for instance, let's call it beta. So, and also, of course, this angle, no? Let's call that theta again. So they are both second quadrant angles. Okay, guys? So number 3 and number 4, I'm going to leave that to you. Number 3, and number 3 and number 4. So you're responsible for them. Set third and so on. Is that clear, guys? Oy, guys, is it clear or head and shoulder?
Clear, sir.
Here po.
Clear.
Here po, sir.
Tayo dyan.
So from this, we are now ready to define the 6
Yes, sir.
trigonometric functions. Yes. A question? You still have question, guys? So we are now ready to define the 6 trigonometric functions of what? Of any angle. So 6 trigonometric functions So let's now define it using Cartesian plane approach. 6 trigonometric functions of any angle, meaning of a general angle, of any angle, and any angle. Okay? Any angle. And so we have, now to define these 6 trigonometric functions, we need, of course, an angle and a point, of course, a point on the terminal side of that angle. So let theta be any angle in standard position. In standard, SP means standard position, huh? With a terminal point, with a point denoted by P, coordinates X and Y. So be an angle in standard position with a point P on its terminal side other than the origin. What do you mean by other than the origin? Other than the origin. What do you mean by that, guys? Let theta be any angle in standard position with a point P whose coordinates X and Y on its terminal side other than the origin. Meaning that P cannot be the origin. Is that clear, guys? Okay, guys.
Yes, sir.
Yes
Clear
po.
po.
Hindi po
Okay.
0-0.
And also, and R, which is equal to square root of X squared plus Y squared be the distance of P from the
Origin.
origin. Okay? Yeah. So let's illustrate. So we have this Cartesian plane, y-axis. So we have this x-axis. So let's have the angle. Let my angle be here. The terminal side is here. I can't hit the origin. Yeah. So this is the terminal side, initial side. Let my representative angle be this angle. But of course, it can be clockwise if you want, as long as in standard position. This is just an arbitrary representation of that angle. So on the terminal side of this angle, so let's say this point, it can be anywhere, as long as not the origin. So that is named as what? As P, coordinates X and Y. So yeah, we say that radius, that is actually radius. We call that radius or simply R. R is equal to square root of what? Yeah. X squared plus Y squared. Now, is R possible to be 0, guys? Is R positive to be 0? I mean possible to be 0?
Yes.
Huh? Yes or no? Is R possible to be 0? Oy, guys.
No.
Is R possible to be 0?
No, because
Yes or no?
no.
Huh?
No.
I can't hear.
No, sir.
No. Why is it no?
Because the point can never be at the origin.
Yes, because the point is not at the origin based on the condition here. When we define the the theta, no? So there. Okay? No, so from here, we now read the 6 trigonometric functions. Actually, this x is the distance from the what? This x is the distance from the y-axis, no? And this point is the distance. This point is the distance from the x-axis. That's y. From the y-axis, this is x. And we define the following 6 trig functions. So number 1, sine theta. What is sine theta, guys? Y over R. So that is how we define it. So did we define sine theta to be y over R, and this is our R. So it's just like defining 6 trigonometric functions of positive acute, but here our theta not limited to between 0 and 90. It can be any this time. So we generalize the definition. Instead of opposite over hypotenuse, we now have y over r. Okay? So because y and x can be possibly negative, unlike in the right triangle approach. What about cosine theta? X over r.
X over R.
Tangent theta.
Y over X.
Y over x. So these are to be memorized. What's the condition for x? Not 0. Meaning, your terminal side, if you have theta, if lying on the, let's say, y-axis, if lying on the y-axis, tangent is undefined. So any point on the y-axis, so you will have tangent undefined. What about cosecant theta?
R over Y. Just the reciprocal po.
So r over y. We do not want y to be 0. So meaning we do not want your point lying on the what? On the x-axis, no? Pag lying on the x-axis, y is 0. This is r over x. If lying on the y-axis this time, x is 0, so we do not want that. Okay? And the last one, opposite of tangent, cotangent theta. Don't forget to put the angle, ha? Without angle, so it's useless. 6x over r, where y is x over y, I mean, not equal to 0. So these are the 6 trigonometric functions of any angle. So we generalize, these are the definitions. From now on, you're going to use this. Special case, if theta is in the first quadrant, then you will have right triangle approach. That is, let's say if your angle is between 0 and 90. Special case. Find the 6 trigonometric functions. Find the 6 trig functions. Trig functions of theta having the following terminal point with a point on its terminal side, with a point on its terminal side, with a point on its terminal side, let's say the point is -5 negative 12. In what quadrant does it fall, children?
Third quadrant.
Third quadrant. So we say that theta is what? It's a third quadrant angle, no? So it's a third quadrant angle.
Yes, sir.
X1. Third quadrant. Sorry for that. I think I have to redraw. So 12. I'm not going to count 12, huh? So this is negative 5. And this is negative 12. Let's just assume it's somewhere here. Then we draw the angle passing to this point. Let's draw an angle. Oops, I can't hit that one. It's hard to hit that point. So this is the point, the terminal point. We call this terminal point negative 5, negative 12. So we can draw an arbitrary right triangle there. So it means this is negative 5 and this is negative what? Negative 12. They are directed, right? And what is supposedly the R? Or what is the R, children? To compute for the R is square root of negative 5 quantity squared plus negative 12 quantity squared. What is that, children?
Is it 13?
Square root of
Square root of 169, and that is equal to 13. Okay, now? So we can now define the 6-3. So how do we define sine theta? Y over. So what is y here? X is negative 5, y is negative 12. So what is y? Negative 12 over 13. Normally we put the negative before the fraction. What about cosine, children? Cosine theta. That is x over r, or negative 5 over 13. What about tangent theta? That is y over x, which is 12 over 5. And then the rest, just reciprocal, because we studied already reciprocal functions. So what is the reciprocal of sine theta, children? Hoy, what is the reciprocal of sine theta?
Y over R?
Over 12.
What is
I
the
know,
reciprocal?
R over Y, R over
What
Y.
function?
Sorry.
What function? Reciprocal of sine theta.
Cosecant theta.
Cosecant.
Cosecant theta. What is the reciprocal of sine theta without using cosecant theta? 1 over
1 over sine theta.
theta. So the reciprocal function of sine theta is cosecant, not 1 over cosecant, ha? Sine theta is equal to 1 over cosecant, but the reciprocal of sine is cosecant, meaning the reciprocal of sine is 1 over sine, and 1 over sine theta is equal to cosecant. Because some of you, when you posted the answers to those questions that I asked you to answer, many had 1 over something. So this is negative 13 over 12. This is negative 13 over 5. And finally, positive 5 over 12. No? Yan, 5 over 12. Is that clear now, guys?
Yes, sir.
Applying reciprocal functions. I can't erase. Number 2. Let y equals negative x be the, let y equals negative x, I said, let the terminal be in loton. No? Let the terminal side of theta in standard position on the line y equals negative x. Okay? Where theta is in quadrant 2. Where is theta, children? Quadrant 2. Evaluate. Evaluate. Let's say sine theta plus cotangent theta all over negative, let's say cosine theta minus secant theta. Yan. What is the value of this expression given this info? So solution or homogeneous mixture. So we have, let's draw. So let's draw that. I can't make a straight line. It's hard to make. So we have, where's the location of theta, children? In quadrant 2. But its terminal side lies on the line y equals negative x. So let's draw y equals negative x. Y equals negative x is a line dividing the second and third quadrant into two equal subplanes. No? Yan. So this is supposed to be the line y equals 2. Yan. It is where the terminal side of theta located. No? So let's have so here, that's the terminal side located on that line. Okay, so this is the line. That is the line y equals negative x. Is that correct, children? Guys,
Yes,
I can
sir.
take any point
Yes, sir.
here, no? I can take any point. Let's say I take a point that is somewhere here. And assume that this is 1. Assume that that is 1 here. And of course, here is negative 1. No? This is 1. So I can take P as what? Let P be equal to negative 1, or let X. I can assign to any X, no? So if I assign X, let X be any value as long as it is in the second quadrant. Negative 1, pwedeng negative 2, negative 3. Then, ang y natin is 1. So I put already there. And what is our R? Square root of negative 1, quantity squared plus 1 squared. Getting square root of 2. Okay? Square root of 2.
Yes, sir.
So this is the arbitrary triangle. Then, so this is 1 unit. This is 1 also, but negative 1 directed. That is the length directed. positive 1. So I can now read from this arbitrary triangle. No? So, or from these values of x, y, and r. So I need sine theta. So sine theta minus plus cotangent theta all over yan, cosine theta minus secant theta. So what's now the value, guys? Sine theta. What is sine theta? 1 over square root of 2. Is that right? Oh,
Yes, sir.
Yes, sir.
negative 1 over 1. This is negative 1 over square root of 2.
Yes, sir.
And then minus, of course, just take the reciprocal. It is now positive, right? Guys.
Yes,
So how to
sir.
simplify? We multiply by what? By the existing LCD of all the fractions involved. So multiply by square root of 2 over square root of 2 so that we can easily get rid of the denominator. So this is now 1 minus square root of 2 all over, this is negative 1 plus 2. Oh, correct, guys? So what's now the answer? 1 minus square root of 2. Okay, so that's the answer. A question, am I right? Because if I'm not right, I am left. Ay,
Oh.
Yes po.
okay. So that's it, no? So you have to know or recall how to graph line, no? Let's say I say y is equal to negative 2x, y equals 2x, you should know, no? You can let any value of x you want. But of course, as much as possible, you let the smallest value possible that you can have. Para you can easily simplify what is asked. Okay? Hi guys. Okay now?
Yes
What
po.
if you're asked of this? Find the six trig functions of pi. What? No, not pi. 3 pi over 2. What are the six trig functions of 3 pi over 2? What is 3 pi over 2, children of the Philippines?
270.
270 degrees. So let's draw. This is y, and 270 is in the y-axis, no? Okay, let's draw the terminal, the initial. What's happening to the line? So I can take any point. Or what's the best point to take? So let it be here. What value am I going to take? Guys? Let what?
Pwede bang 3 and 4, sir?
Let P be what? Of course, the other one is 0 automatic.
Negative.
What's the
Ay, yung
best?
ano.
Negative 1, no? You can have negative 2, negative 3, negative 4, as long as negative because it is along the y. So let P be our Pxy. Okay? Guys? So why did I choose 0, negative 1? Because it is in the what? On the y-axis, no? Any point on the y-axis takes the form 0, let's say negative a, where a is positive. So,
Sir, why was it 0 automatic?
di ba 0 ang x dito sa pag nasa, let's say itong point na to, what are the coordinates of this point? Ano ang x nito? Di ba 0? Iha? Am I right? O 0. And I want it to be any number, so I chose negative 1. because it can be on the y-axis. Any point on the y-axis can be -1, -2, -3, even negative square root of 5. So, but the best to choose -1. You don't have to worry. You'll get the same function values. Oh, what about sine 3 pi over 2? How do we define sine function? Y. Or what is our x value? 0. What is our y value, guys?
Negative
1. What is r? Square root of 0 squared plus -1 quantity squared. So it is +1. So that is y, -1 over
1.
what? 0. So it means, sorry.
1,
Undefined.
sir.
No, it's 1.
Negative 1 over 1.
So
Sorry.
-1.
Negative 1.
So we can now define immediately secant or cosecant of 3 pi over 2. What is that?
1 over
also,
-1.
no? -1 also because just reciprocal. What about cosine of 3 pi over 2?
0 over
Is
1.
0 over 1. That is x over r. So 0. So what about secant of 3 pi over 2?
1 over 0.
That is 1 over 0 or undefined.
Undefined.
Let's put 1 over 0 or undefined. Okay? What about tangent? Tangent 3 pi over 2.
-1 over 0. Or
-1
undefined.
over 0. Then it is also undefined. What about cotangent? So cotangent therefore is defined. 3 pi
0.
over 2 because the reciprocal. So if it is undefined, the tangent, cotangent is defined. And that is 0 over -1. Is that correct? So this is equal to 0. Okay? So from this, you can now derive also other what? Other 6 functions of quadrantal angles. No? So let's summarize. Let's say I have theta here. And so we call this functions of quadrantal angles. Sa summarize natin. Trigonometric functions of trigonometric functions of quadrantal angles. Those that are basic only. Quadrantal angles. What are those basic quadrantal angles that are positive together with 0? 0, 90, 180, 270, and 360. Once you know them, actually up to 270 only. Once you know them, there is no way for you not to know the 360, functions of 360, -90, -270, because those are just coterminals of one of the basic here, no? Basic quadrantal angles. So let's say I have theta here. Then I have sine theta. Sine theta. Let me move a little here. Sine theta. And then cosine theta. Then we have tangent theta. And then cotangent theta. What else? Cosecant theta. And finally, cosecant theta. No? So theta, by the way, what is our theta, guys? Let's start with 0 degree, no? Or 0 radian. 0 radian or 0 degree. 0 radian. So then we have 90 degrees. That is pi over 2 in terms of radian. 180 degrees. That is equal to pi. No? Then 270 degrees. That is equal to what? 3 pi over 2. Okay? Now the 360, even I don't write it because it is coterminal to 0 degree.
0.
So they have just the same function values actually. Okay, guys?
Yes,
So we
sir.
have
0,
0.
1,
I know. So 1. Sorry. 1. What about here?
0,
0. Then
undefined,
undefined. Ande.
1,
So meaning undefined. 1. Ande. Undefined. So this is 1. 0.
undefined,
Undefined. Then this is
0,
0. Undefined.
1,
Right? 1. What about here? 0.
0,
Negative
negative
1.
1,
0. Right?
undefined,
Undefined, negative 1, undefined. And then finally, we have
negative 1,
negative 1, 0. Is that
undefined.
correct?
Yes, sir.
Undefined,
0,
0. No, 0, sorry. 0. Then undefined, right?
yes,
And
sir.
then
Negative
negative
1,
1. Again, for 360, let's write 360 na rin. Pag 360 to 2 pi, what are the function values? Paras lang here, 0 degree. So 0, 1. You can derive if you want. No? 0, undefined. Secant is 1. Then undefined cosecant. Okay now, guys. So an here yan, means undefined. Means undefined. Okay, do not use infinity. Ha? A question, guys.
yan, sir.
Okay. I will be posting in your Canvas some exercises that you're going to submit. Then you're going to, what you call this? Paste your solutions in the Excel that I'm going to provide. You will see, or you can download the Excel from the Canvas discussions. But once you upload, you're going to upload it in the Canvas quiz. So there, you just look for the title of the activity, then you upload there your file, one file only to be uploaded, where you're going to paste your solution. A question, guys, here? Oh, guys, is there questions? So, okay, so no. So let's now talk about angles, sign of angles in a quadrant. Just sign of angles in a quadrant. Okay? So we have algebraic signs. It's almost time. So we call this algebraic signs. Of trigonometric functions. Trigonometric functions in the quadrants, no? In the different quadrants. So I'll just draw the Cartesian plane. So just so to summarize, no? And we have here. And I will list down those that are positive in this quadrant. And so in quadrant 1, what functions are positive? All functions. All trigonometric functions, function values, all trigonometric function values positive in first quadrant. Because the first quadrant angle is, is represented in the right triangle approached by a positive acute. So even the angle is negative as long as falling in the first quadrant. So all the function values are positive. What about in the second quadrant? What are
Only
those
sine and
positive?
cosine.
Okay, so sine theta
And cosine.
Cosecant Theta. Reciprocal
Cosecant.
niya. Ito yung positive. The rest, what?
Negative.
Negative. So, ang negative, yung others, no? So,
Yes.
other functions, other trig function values, yan, negative. Yung mga wala dyan. Ano yung mga wala? Cosine, secant, tangent, and tangent. What about in quadrant 3? What are those that are positive?
Tangent and cotangent.
Tangent only and cotangent. By the way, theta here can be replaced by any other name. Huh? It doesn't mean always theta. So other functions, other trig function values are what? Are
Negative.
negative. Pag wala dyan, negative. Yan. What about in the fourth quadrant?
Cosine and secant.
In the fourth quadrant, we have cosine and
Secant po.
secant. So, cosine function and secant. May mga acronym na ginagawa sila, no? So that you can remember, no? Yan. Yung isa, ASTC. Yung iba naman, all students, all smart students, What about C? I do not know what. Merong all is smart. Merong whatever. I forgot. So other trig function values. Yung iba, all students take calculus. Ayan. All
Sir, add sugar to
students.
coffee.
Huh? Sorry?
Sir, add sugar to coffee.
I did not understand.
Sir, he's saying that add sugar to coffee is the acronym.
So it's up to you. You can have any, you can find many acronyms just to memorize it. But I memorized this already, so I don't need the acronym. You just remember A. A meaning all, S meaning sign, and of course automatic, it's reciprocal positive. And then T, C. Okay? So these are positive. Yan, positive. Yan, positive values ang kanilang, no? So together with reciprocals and their reciprocals. Reciprocals. Ano yung mga reciprocal nila? Respectively. For sine, cosecant, for pagtangent, yan. Cotangent, cosine, secant. Okay now guys? Yung iba ax. Pero ang rotation nila pag ganito, clockwise. Pag ang rotation mo counter as ASTC. Pag ito counter clockwise. Ito counter. Okay guys? May question pa?
None, sir.
Okay. So that's it. We'll continue next meeting. By the way, just watch for it. I mean, just monitor if we will be meeting tomorrow. Ano bang oras kayo ng blending pag tomorrow ba kayo o pag Friday?
Thursday po.
Thursday. So you just wait for the announcement if we will meet tomorrow, huh? Because we are late because of many suspensions. We have 2 Mondays already that we did not have class. Is that okay, guys? I just what you call this? Check if there will be an announcement. Okay, that's it. Goodbye, class. Thank you.
Thank you po.
Thank you po.